So let's continue. Now we have done 90 degrees, 60 degrees, 45 degrees, and of course 30 degrees. In this case, 30 degrees, we can write that as pi over 6, or 30 degrees if you want, doesn't matter. So now if you look at this, same idea, except that this is 30 degrees or pi over 6, doesn't matter which one you write down. So same thing, this is unit circle, right? So same thing, and we are going to take advantage of this. The 90, 60, 30. Okay, yes, we did that for the 60 degrees above, but this time the angle we are looking at is going to be 30 degrees. So let me just write down the length here, 2, root 3, and 1. So if you draw this time the reference, the angle we are looking at is 30 degrees instead of 60 degrees. So this is 30 degrees, and this is of course a right angle triangle, and this one would be 90, that would be 2, and the 30 degrees would be, this one would be 1, this one is 60 degrees, and this length would be root 3. Same thing, we want a unit circle, so the hypotenuse should be 1, but it is 2, so what do? Divide it by itself, so that gives you 1, and then divide everything else by 2. Okay, so that means the width here is root 3 over 2. The height here is 1/2. So what is the coordinate of this point? Root 3 over 2 and 1/2. So root 3 over 2 and 1/2. Again, we can do the same thing. So this would be negative root 3 over 2 and 1/2. And again, I know you're getting bored. Oh, sorry, there should be a solid line. And bear with my drawing. So the coordinate here would be negative root 3 over 2, except this one is going down, so negative 1/2. And of course, there would be 1 here. This is now 30 degrees instead of 60. Okay, so this one would be root 3 over 2 and 1/2. And before I move on, I would like you guys to check out this video, which summarizes some of the stuff we have talked about, the unit circle song. Trust me, this will be very helpful. I mean really, really helpful. And I would like you guys to check out these two videos as well. They will help you memorize something very, very helpful. And with some tricks here. I'll show you my trick in a second, but definitely check this all out. So, if you jot down all the information we just derived, I'm going to quickly sketch this. So 30 degrees here, and then jot down the coordinate, and then, oops, wrong color, and then 45 degrees, well, it's a bit messy, 45 degrees, and then jot down the coordinate here, and then 60, jot down the coordinates here with what we derive on the other side, then you should see this. So you might want to pause for a few seconds, double check at least if I copy down stuff right or not, but Cheng is always right. So jot down all the information and then start from 0 degrees here. Look at the coordinate. I would suggest you to look at the x coordinate. Look at the y coordinate. What happens as you go around. Okay, and then just focus on this one here. Look at the x coordinate values, look at the y coordinate values this way, starting from 3 o'clock, go to 12 o'clock, or from 0 degrees, go to 90 degrees. I hope you see something, some pattern, very consistent pattern. Okay, so let's move on here. the coordinates are reflected over the x and or y axis as we move from quadrant to quadrant, and then every 90 degrees the coordinates switch and signs change according to the quadrants. So we sort of touch on that, except I never um, pinpoint that exactly. For example, if you look at this, this is root 3 over 2 for the x value. This side, negative root 3 over 2, they match. This one, 1 over root 2, negative 1 over root 2. Let's look at the y. This is, if you look at the y here, y value for this one is 1/2. Y value here going down, negative 1/2. This one is 1 over root 2 for the y value. Down here, the blue one, this one here is negative 1 over root 2. So they match, except the signs are flipped. Assuming you have watched those videos, and I don't know if those tricks make sense to you, so I'm going to pass on Chang's technique to you. So if you look at this, I am going to cheat a little bit. This is something you will learn on the next lesson. The x coordinate of each one represents the cosine function. How does it work? I'll show it to you in the near future. Each y coordinate represents the sine function. So if you look at this, the x coordinate represents a cosine function. So look at the values. Look at this. We go from 30, 45, and 60. Okay, this is what I'm going to use very often for the rest of this unit here. What values do we have? For 30 degrees, root 3 over 2. Next one, 1 over root 2. I'm not going to use this one here because it doesn't show something that's so obvious. Instead, I wrote down root 2 over 2. I know you say, Chang, 1 over root 2 and 2 root over 2, they are not the same thing. Yes, they are actually the same thing. So 1 over root 2, let me just do it here. 1 over root 2. If you rationalize the denominator, what do I mean by that? Multiply the top and the bottom by the same thing. Root 2 over root 2. Then root 2 times root 2. That will give you 2. On the top, 1 times root 2 gives you root 2. So now 1 over root 2 is the same as root 2 over 2. Okay, so instead of saying 1 over root 2, I would write down root 2 over 2. And then this one is 1/2. 1/2. Let's look at the y value. The y value represents the sine. So the first one is 1/2 for 30 degrees. And then 45 degrees is 1 over root 2, or more preferably root 2 over 2. And then at 60 degrees, the y value would be root 3 over 2. Now, if you look at this, look at the bottom. They are all 2. No big deal. Look at the top. Root 3, root 2. This one, can you call that root 1? Now root 3, root 2, root 1. Everything is over 2. You can see that it's decreasing. This is Chang's technique. Now for sine, it is the other way around. Instead of calling 1, can I call that root 1? Root 1, root 2, root 3. You see, they are all increasing, and again, they are all over 2. They're all above 2 or divided by 2. Not just that. Did you guys realize that the cosine and sine, they go in opposite direction? This one decreasing as the angle increases. This one, as the angle increases, so is the value. So this one is going down this way. This one is going down. Exact same values in opposite direction. Now you may remember how to do tangent. So if you look at tangent, tangent is sine over cosine. So if you look at this, take this, divide by that, gives you that for 30 degrees. For 45 degrees, sine over cosine. This divided by that gives you 1. 60 degrees, same thing, sine over cosine. This divided by that gives you root 3. This is Chang's technique. This would be very, very helpful. Try your best to remember. Now I've taught you the technique. You can start from here. Look at this. X coordinates, Y coordinates. So if you look at this, root 3 over 2, root 2 over 2, 1 half, and then here, 1 half, root 2, root 2 over 2, and then root 3 over 2. You can actually reproduce this. What's the big deal? You will see in the next two questions how handy it is if you memorize or learn Chang's technique or the techniques that you learn from the video clips to reproduce this. Otherwise, the math would be so much more complicated. It's not hard or undoable. It's just harder to do. Okay, so let's do this one here. Find the angle, what is the value of the angle that will give you this coordinate. X is negative root 3 over 2, y is negative 1 half. If you look at the unit circle, just compare the value. Which one has x equals to negative root 3 over 2? Either this or this. And which one at the same time has a y value of 1 half? Not this one, this one. What is that angle? 5 pi over 6 or 150 degrees. So in this case, you say that angle theta would be 5 pi over 6. And if you want 150 degrees. Of course, with this thing around, it would be easy to do the question. But what about if this is not around? This is not on your formula sheet. So how can you figure this out? Okay, this is one way, the easy way. But the deal is you have to, well, do it this way. If assuming you're doing it Chang's way, memorize this or learn this. I hope I taught you the technique that will help you to remember this easily without having to spend 20-30 minutes just memorizing all these numbers, which may not make any sense to you too. And then you can use this to produce this. Okay, because if you look at this, this is 30 degrees, this is 150, because 150 plus 30 gives you 180, 45 matching with 135 here, and then 60 matching with this one, 120. And then you can extend that, but usually we would talk about an angle somewhere between 0 and 90 degrees. Alright? Okay, next one here. Same idea except the other way around. So this time we were given the angle. Find the coordinate. Alright, so the angle is 7 pi over 4. If you can reproduce this unit circle thing, then that would be easy. Angle theta is 7 pi over 4. Where is 7 pi over 4? If you look around, 7 pi over 4 will be right here. This is basically no-brainer. I'm sure any one of you can do these type of questions if you have the unit circle with notation around. But how can you reproduce this? One last time here. So anyway, to answer the question, with an angle of 7 pi over 4, what are the coordinates? 1 over root 2. If you want, you can call that root 2 over 2. And then this one, negative 1 over root 2 or negative root 2 over 2. Either way, I will stick with my notation to keep it consistent. Okay, so in this case, the point with angle theta, which is 7 pi over 4, would have a coordinate of root 2 over 2 and negative root 2 over 2. It is that easy. This is a relatively short lesson because I skimmed through some of the derivation deriving those numbers. Go home, so actually you're at home, sorry, so spend some time reviewing those. All right, so here we go, all the questions you may want to try out.